Again, I love antenna design, and designing high-gain omnis seems simple, but it's actually complicated. So we explained on marine antennas and so forth, you can actually have high gain without messing up the antenna. Again, just to emphasize, Omni is trying to be at best from the top view, azimuth, to be round. Okay, that is the main thing. And many people get gain by making it not round because that's like pushing a balloon. But on the side view, you can actually get gain while it being round. So now here we're looking at antenna from the top, here we're looking from the side. And one of the basics of physics is that this antenna here, that length will perhaps give you this. You need to get longer and longer to get higher and higher gain. So it's typically sitting in a radar. And for example, to get real gain, I explained before why we use dipoles, not monopoles. Here you can see that it's not really possible to use monopoles. So we put dipoles in, and we create an array of dipoles from the top to the bottom. Seems simple enough, hey? But you can't just feed them from nothing. So first problem is, of course, and that we've managed to do long ago. We designed not simple stuff like this. They are very complex dipoles that perform all the way from bottom end to top end. Whatever spec is, very often 600 to 2.7, lately higher and higher and higher as people want to go higher. But the real trick is that if you just interconnect these things in a so-called series connection, it will never work because they need to stay in phase. Now, they may be in phase at 600 megahertz, but at 900 megahertz, the wavelength has got shorter, and you'll find that the beam would oscillate up and down, which is, by the way, why any of these little goodies that you sometimes buy, very low cost, they used to work at 900 megahertz because these things will keep the whole thing in phase. Absolutely useless if you try to go across the frequency band. So in this case, what we do is we actually put a cable of the same length. So I won't draw it, but this one is coiled, this one is less coiled, and we feed each of them in parallel. Then if they are the same length, then you get proper antenna behaving right across the frequency band. A lot of trickiness here because these cables that now have to go, the top guy has to go past 3 and so forth, does mess up the pattern here, okay, because it starts causing reflections. Many tricks like the secrets of MIMO and other tricks that can be used to alleviate this, but it is one of the problems that you have to manage, as people say. Horizontal, much more difficult, okay? The reason for that is people asking us now, especially at Wi-Fi, please design us horizontal Omni. And if you look at horizontal Omnis, a normal dipole won't work, eh? The normal dipole, if you look at it from the top, have got a pattern like this. So it won't be Omni, it would just be one way or the other. So what we doing at the moment, and we've done it many years ago, you design an antenna that, for example, have got dipoles around like this, each of these discs, and that now makes sure that enough dipoles and you can go Omni. And by stacking these things, we can get horizontal antennas with high gain. Very important if you're using MIMO. Keep on remembering that your cheapest way to get 2 streams at least is horizontal and vertical. So you can either mix them or put at the moment I think we put our vertical bit higher up, because the one lucky thing on the horizontal dipoles, they're not very sensitive to cables running past them. And then we route the vertical, and we do vertical as well. But tricky stuff, and just showing you the little bits and pieces of how to do that effectively.